Hello and welcome to today's presentation. Today we will be talking about the geoids and how we can use them in 3D survey. So let's go right ahead. First, let's have a look at what actually is a geoid model. So a geoid model is a model describing the Earth's surface, and its shape would be basically the shape of Earth's object if we extended the oceans beneath the continents. So why is this important? Because in land survey, when we measure heights from the geoid model, because these are the measurements that we get when we measure heights with a total station or a nivelier. But the problem with the geoid model is that it's hard to describe it mathematically. So it has an irregular shape. So GPS receivers, they usually give us the ellipsoidal height. Here in this picture, we see the difference. So the orthometric heights, so those are the ones that we are using in our survey maps. Those are different than ellipsoidal heights. And the difference is the value of geoid height or geoid undulation. So because our end results will be in orthometric heights, we need to use geoid heights to fix the ellipsoidal heights that we get from drones in order to be able to use both survey GPS heights and GPS data from the drones. And what does the shape of the geoid model looks like? So we said it has an irregular shape. So generally we have higher geoid model in area where we have a lot of mountains. The highest value of geoid is around Iceland, where the geoid is 85 meters above the ellipsoid, and the lowest value for geoid model is minus 100 meters, which we have around southern part of India. It is important to note that we have two types of geoid models. First type is global geoid models. Examples of these are EGM-08, EGM-96, and yet to be released EGM-2020. So the EGM stands for Earth Gravitational Model. As the name suggests, the global geoid models offer global coverage, but an obvious downside will be that they offer lower accuracy. What kind of accuracy we can expect from EGM models, we will see in a little bit later. So here we have three different EGM models. One is yet to be released, and we also have EGM-96 and EGM-08. So we did some tests with these geoid models, and it seems to us that actually the EGM model 96 is more accurate than EGM-08. So that's why we have decided to add this one with 3D survey. So EGM-96. On the other hand, we also have local geoid models. Examples of these are G12B for the US, so that tells us geoid from 2012 data, B version of calculation, and US for the state. Or GCG 2016 for Germany, or KN Geoid 8 as in Korea National Grid 2018, or GS, or the last one is Japanese one. Here we have a picture of a Greek geoid model. So these local geoid models, They offer state or country-wide coverage. They have considerably higher accuracy than global geoid models, and they're typically used in survey-grade GPS instruments. So your survey-grade GPS instrument, by default, it gives you the ellipsoidal heights, but then on the GPS instrument itself, also a local geoid model is already installed, and this is what enables you to get orthometric heights directly from your GPS without needing to worry about the geoid models. So, what is practical difference between local and global geoids? So, I opened a project that we did here in Slovenia, and I first used the global geoid model on the telemetry data, and then I also used our local geoid model on the same data. So the difference will only be in the altitudes of our data. So if we do the calculation, so 429.806 minus 429.229, we will get to approximately 60 centimeter difference, plus minus 1 millimeter. So that's quite a lot. When we have very accurate telemetry data, global geoid models would not suffice. So our practical guidelines are such: if you are using an RTK drone, we recommend you to use local geoid model with your telemetry data. On the other hand, if you are using a non-RTK drone, then even half a meter accuracy should be sufficient. If we check the accuracy of the telemetry data, in case of regular phantom drones, we see that X precision is around 5 meters, Y same 5 meters, and in vertical direction this is even less, so even 10 meters. So the accuracy of the telemetry data is considerably less than 1 meter. So in this case, I think we don't need to worry that much if the geoid model gives us half a meter error. So the telemetry information won't play a big part in the adjustment, in the bundle adjustment. So the global geoid model should suffice in this case. On the other hand, Phantom RTK reports telemetry accuracy of around 2 centimeters in horizontal direction and double that in vertical direction. So in this case, accurate geoid model will add a lot of benefits. So let's have a look at how we now import the geoid model. So I think you probably already noticed this. So now when we are importing the telemetry data, we can set also the vertical coordinate system of telemetry. So by default, usually your telemetry coordinate system will be in WGS84 coordinate system, and the drone will be writing altitude information in ellipsoidal heights. So then we set our horizontal coordinate system in which we want our results. So in my case this was Slovenia, in your case that might be something else. And we can also set vertical coordinate system of our project. So we set it to the geoid model of Slovenia Copper 2016. Here in my vertical coordinate system list, you will notice that I have a couple of different coordinate systems. So we made the software so that we can import different geoid models into it. So by default, everyone has EGM96 geoid model. And then you also have an option to install various local geoid models. I, for example, have Germany, Slovenia, and California. And then there is also an option to manually insert the geoid undulation or geoid height above the VGS84 ellipsoid. So there is also always a manual option to set this offset manually. Now let's have a look at a little bit about the different geoid model data formats. We noticed that the geoid models come in many different data formats. So here are listed just a few. So the second thing about the geoid models is they come in this kind of matrix form. So sometimes this will be a row major matrix, sometimes it will be a column major matrix, sometimes the first row will give you the information of the maximum latitude of our grid, sometimes this will be the minimum or the lowest row of our grid. So the import of data can be a little bit tricky. And we need to check our data quite well in order to not make some gross error. So with this in mind, we decided to use our own data format for our geoid models. Currently, we are building a database of geoids, and also a website for this database is under construction. For now, if you need your local geoid model, please contact us on our support email at support@3dsurvey.si. Now let's have a look at practical example of how we can import a geoid model in 3D Survey. So I already have 3D Survey opened here, so I'll just go to new project. Now let's load in some images. Here I have a couple of images, so these were recorded in Slovenia. Images were recorded in Slovenia, but I don't have a Slovenia geoid model. So what I need to do, I just need to run this simple installer, which will add the Slovenia geoid model to 3D Survey. So just double click on this one. It finishes pretty fast. Now let's just restart 3D Survey. Load in the images again. And now I have here also Slovenia geoid model. So this is great. The telemetry information is in WGS84. The drone wrote ellipsoidal heights, but for our project we want to convert them to Slovenia coordinate system and Slovenia vertical coordinate system. Just import. Okay. Close. If we want to check it out, we can always also import some ground control points. So here we had just a few. Import. If we check in telemetry, we now see that the height of the cameras is approximately 60 meters above the height of the GCPs, and our flying altitude was around 60 meters. So that makes sense. And this is also how we can easily check if we have correct values. So if we set the geoid model incorrectly, it wouldn't come so that we would take GCP altitude of 350, add 60 meters to it, and you come to around 410. So this is how we can do an easy check. Okay, so another thing to notice. Probably you remember from the 3D survey version 2.8.3 that sometimes you received this kind of window when you were doing the orientation. This was actually our solution in version 2.8.3 of how to deal with the geoid models. So in that version, we automatically detected if the position of cameras that was obtained from telemetry and position of cameras from orientated with ground control points, if they differed, we brought you these offsets and we asked you to confirm those offsets. So this solved pretty effectively any problems you had with not having the geoid model or incorrectly setting the coordinate systems. So this window is now no longer present in version 2.9.0. So in 2.9.0, if you don't have a geoid model, or if you have maybe some problems with the coordinate system, then it's important to use the local coordinate system when importing the ground control points. Using local coordinate system tells 3D survey to calculate the offset between the GCPs and telemetry information and use this offset in orientation process. So if we are certain about our coordinates, then we can also use non-coordinate system. So this is what is new now. Now let's have a look at a practical example. So here we already have now set up a project. Now let's also process it. So I will run bundle adjustment, global, so this will take a little bit of time and we will just skip ahead to when the bundle adjustment is finished. Okay, so the bundle adjustment has just finished. So now we can do orientation with ground control points. For this example, we will set all the ground control points to validation. So this means that the ground control points won't be used for georeferencing of our model, they will only be used to check the accuracy of it. Press next. So here we now already have approximate positions of our GCPs. That's because we have now a lot better telemetry information on the drone. So if we just mark a couple of ground control points now, there will be a third one. Here is another. Okay. So this will now already be good enough to do the automatic detection of targets. Great. The automatic detection ran perfectly. Let's just export these values so that next time we don't need to click. I'll just use GCP detections 1. Okay. Next. Now let's see what accuracy of model we would obtain without using any GCPs for georeferencing. So we're just using them for checking the accuracy of the data. So in this example, that worked pretty well. So the accuracy of our model in vertical direction is in this case around 2.5 centimeters maybe. So that's already enough and pretty good. But now let's have a look at what would happen if we incorrectly imported the telemetry information. So now everything was done correctly. But for second example, I will re-import the telemetry information. I will import it from EXIF data. And here I will now set it incorrectly, for example, to ellipsoidal heights. Press re-import. Okay. Telemetry information was successfully imported. Here we can already see that this doesn't look like right anymore. Now let's repeat the orientation with GCPs. Now, for example, let's set 4 GCPs, 4 ground control points to GCPs, and we will set 1 to validation. Press next. And note that we have incorrectly imported the telemetry information. So the GCPs are now already marked. Just press next. The detection still works fine. Let's go to last step. Okay, so already we see that we got a pretty lower quality estimated errors. So this point that was used as validation is now off by 12 centimeters, and even the rest of the ground control points don't fit so well anymore. If we press finish, we can already see that the shape of our photogrammetric model is no longer so good. So this is because we now have incorrectly set telemetry information. But there is still an option to improve the quality of this dataset. Now we will just repeat the orientation process. We will now re-import the GCP points. So we have them here. But now we will set the coordinate system to local coordinate system. So that means that the coordinate system of GCPs will overpower the coordinate system of telemetry data. Import. Again, let's set a GCP to validation. Let's press. Now also let's import the already pre-calculated GCP detections. Press next. Next. So these are now the same GCP detections that we used for previous step. And next again, and let's see what kind of accuracy we get now. Okay, we already have our result. So now the overall accuracy is considerably better And also this validation point that we used is only 2 centimeters off, less than 2 centimeters off. So this is about, I would say, the accuracy of the GPS measurements. So pretty well. Finish. And this is again how correct photogrammetric model looks like, even if we have incorrectly set up telemetry information. Okay, so important things to take away from this presentation. Use your local geoid model if you are using an RTK drone. Ask us to provide you with the geoid file. Just send us an email at support@3dsurvey.si. Eventually, the geoid models will be available for download from the downloads section of our website. And last but not least, if you experience low accuracy after GCP orientation, just repeat the GCP orientation with local coordinate system settings option. So this will likely help a lot. If this doesn't help, again, just send us an email at support@3dsurvey.si. So that will be it for today. Thank you very much for your attention and happy 3D surveying. Bye bye.